Hello everyone. So in this sections we will discuss about measure numbers and significant figures, right? So measure numbers. What is a measure numbers? Well, I could ask you what is the distance between Greensboro and Winston-Salem? Anybody from here Winston-Salem's? Okay, so what is the distance between Greensboro and Winston-Salem? So you would say maybe 30.5 miles. So how do you come up with that answer? Somebody must have measured and posted online, right? So every time we measure something, we come up with a number. So let's say we have a ruler. Okay, I'm gonna draw as nice ruler as possible. So let's say this is 1, 2, 3, 4, 5 centimeters. 1, 2, 3, 4, 5 centimeters. So what is the minimum distance this ruler can measure? So question 1. What is the minimum distance this box can measure? So what is the minimum distance this box can measure? So what would be our answer? Our answer would be 1 centimeter, right? So we can measure the minimum distance we're using this ruler is 1 centimeter. So let's make it more clear this question. What is the minimum distance this is not a box, this is ruler. Sorry. What is the minimum distance this ruler can measure accurately? So the answer is 1 centimeter. So let's say I have a what do I have? I have a sticky notes. Let's say the sticky notes here. I have a sticky notes right here, right here. So I'm gonna ask, what is the distance of that sticky notes? So question 2, what is the distance, what is the length of that sticky notes? So what would be your answer? Pause for a second here and then tell yourself, and then I'll tell you the answers. So the most accurately, we can say the length of this sticky notes. So length of the sticky notes. So is it gonna be 2 centimeter? Is it 2 centimeter? So we can say it is 2 centimeter, but is it 3 centimeter? Obviously not. So it is in between 2 centimeter to 3 centimeter. So every time you measure a number, so you have to add one extra digit as an estimation. So first, this is you're absolutely sure. So you're absolutely sure that it is above 2 centimeters. Then you're gonna add one guess number. So I'm gonna say it is about 2.5 centimeter. So look what I did there. So the first portion of this number, which is 2, that I'm absolutely sure that it definitely has to be above than 2, right? And the second portion of this number, I have added one extra digit. So this is called estimations, estimated number. So this is estimated by the person who is measuring. So in this case, I estimated it. So every time you make a measurement, so you always add one extra digit on top of your absolute certainty, right? So in this scenario, the last digit is 2. The 5 is our estimated number. Good. So I can say, if I would have said 2.55 centimeter, where do I come up with this 5? I cannot estimate 2 extra digits. So this I cannot do. So I cannot estimate two extra or second extra digit. Sounds good? So I cannot estimate the second extra digit. So this would be wrong. So let's do another example. So I'm going to have another ruler. So example 2. So I'm going to have second ruler. So I'm going to put this in inch. Now let's put centimeter. I'm just going to enlarge the ruler so that I could make this a bit nicer. So this is 1, 2 centimeter. So then the in between are 1, 2, 3, 4, 6, 7, 8, 9, 10. 1, 2, 3, 4, 6, 7, 8. 9. Okay, you got the idea. So maybe I should just do them all. Okay, so question 1. What is the minimum distance? Minimum measurable distance. What is the minimum measurable distance for this ruler? Is this going to be 0.1 centimeter? Right? So 0.1 centimeter. So let's say we have another sticky notes this time. Okay, so this notes, what is the length of this notes? So length of that sticky notes. So the length of the sticky notes would be, any answer? Pause for a second. So is it 1 centimeter? So 1 centimeter, if I say 1 centimeter, then it's not correct. Right? So can I say 1.3 centimeter? Yes, so 1.3 centimeter is the distance that I can say. I'm absolutely sure. If I look here, maybe I should just redraw this one. So I could say it's 1.3 centimeter. It would be a little bit above 1.3 centimeter, but definitely not 1.4 centimeter. So it's not 1.4 centimeter, right? So it's not 1.4 centimeter. So this is, you can say this with absolute certainty. So what do I mean by that? Because the minimum measurable distance by this ruler is 0.1 centimeter. So if I look at the ruler and I can say it would be 1.3 or 1.4 or 1.5 or 1.6. So I can add one place after the decimal. So that's absolute certainty. So let me rewrite again. So 1.3 is, we are 100% sure it is above 1.3. So this is 100% sure. But remember the rule. So you always have to guess one extra number. So in this example, what would be my guess? I would say 1.31. So the guess is up to you guys. You can guess whatever you want to guess. All I want to see is that extra digit. So I can guess. So the number is 1.31. So the last digit, maybe I should just guess 1.32. It doesn't matter. So the last digit here, the 2. So the green portion is 100% sure. And the last digit here is my estimations. And how many estimations I can do? I can always estimate one extra digit, right? So my estimation, and it is always one digit. one extra digit. All right. So this is how we measure. So I cannot do 1.325. This would be wrong. You'll get 0 points on this one. So this is wrong. This is wrong. The correct answer is 1.32. You can say 1.33 if it looks to you 1.33, if it looks to you 1.35. So the estimation portion is up to you what you want to put, but like be reasonable, not like put a wrong estimations, right? So that means you are wrong. Okay, any good? Any questions? So this is how we measure. So every time we measure, we're gonna have some units, right? So all the measurements comes with unit. So just look at the couple of things that we measure. What are the things we measure? We measure temperature, right? We measure temperature. What is the temperature of units? We know use degree Celsius, degree Fahrenheit, but we're gonna be using degree Celsius because that's the scientific units, right? What else we measure? We measure distance. What is the unit for distance? You guys know the unit for distance? Yeah, you can measure the distance in meter, centimeter. You can measure the distance in kilometer. You can measure the distance in light year between the planets. So there are a lot of units we have, but we're gonna be using metric and SI units, right? So metric unit for distance is gonna be meter. So which is M, and SI unit for this one is also meter. SI stands for scientific international standard. So this is also meter. Then what else we can measure? We can measure volume. How much milk did you bought? You bought 1 gallon? No, don't use any gallons, right? So the scientific units, the metric units is gonna be our liter, and the SI unit is called meter cube. So it's cubic meter, m cube, m to the power of 3. So this is our cubic meter. By the way, 1 cubic meter is 1,000 liter. So what is a 1 cubic meter? 1 cubic meter is if you have a box which length and everything, every side is 1 meter. So it's 1 meter length, 1 meter height, and 1 meter width. That would be the volume of that box is gonna be 1 cubic meter, and it would contain 1,000 liter of anything. 1,000 liter of oil, 1,000 liter of gas, 1,000 liter of stuff. Then what else we measure? Mass, right? We measure mass. Do you guys have a kitchen balance? So we measure mass. What is the unit? No ounce, right? Obviously we can measure in ounce, but we're not going to be using ounce in our scientific community. The metric unit for mass is our gram, and SI unit is kilogram, which is, yep, so kg. So we will be using a lot of these units, and for simplicity we're going to be using all of them in either one of metric or SI units. But in the problems I might ask you what is the conversion factor between these two. So we'll talk about conversion factor later in like few lectures away, so don't worry about it. Let's do temperature. I just said temperature is degree Celsius and degree Fahrenheit. So degree Celsius is our metric unit. For degree Fahrenheit is not the SI unit. The SI unit for this one is Kelvin. So it's called Kelvin. So you will be using a lot of Kelvin later in the class. So just know for this one. And what else we got? We got, Yeah, what else we measure? We measure time, right? We always measure time. Time is always it's the metric unit is seconds. This is also second. Cool. Well, you can measure time in hour, but these are the metric and SI units, international standards. Okay. Okay, I'm gonna stop right here because this video is getting a little bit longer. We'll